Okay, reciprocal function family. So we're going to talk about the reciprocal function, which looks like y is equal to 1 over x. So this number 1 can be any other number. And basically when you have x in the denominator at the bottom, then we call this inverse or reciprocal function. The name inverse comes from the inverse relationship, the number on the top and the x in the bottom. And the reciprocal meaning 1 over x is reciprocal of 1 x over 1, which is x. So that's the name of this function. And let's try to graph the most basic form of the inverse function, which is y is equal to 1 over x. So if we create a table and then plug in negative 10, y will be negative 1 over 10. Plug in negative 2, I'll get negative half, negative 1. If I plug in 0, I will get 1 over 0, which is impossible. So this will be none. If I plug in 1, I will get 1, 2, 1 over 2, 1 over 3, and 1 over 10. So if I plot these points, when x is negative 10, y will be negative 1 over 10, which is really close to 0. So let's plot maybe a point here. X is negative 2, then y will be 1 half, which is still close to 0, but not as close to 0 as that one. So it will be about half point between 0 and negative 1. Negative 1, I will get negative 1. And if x is 0, then I won't get any point. What if x was like negative 1 half? So what if we had negative 1 half? What will be the y? Well, 1 over negative 1 half will be the reciprocal of this number, which is negative 2. So if x was negative half, I will get negative 2. If we connect these dots, you realize that x will never be 0, and also the graph will never ever touch the x-axis. It's gonna come really close to x-axis, but it's never gonna touch. That means x-axis is the asymptote, and also the y-axis is another asymptote. Just plug in 1, 1, and 2, half, 3, 1/3. If you increase the number like 10, I will get 1 over 10. So bigger the x values are, smaller the y values become. But the y value never becomes negative or 0. If I plug in 1 over 2, like half, reciprocal of 1 over 2 will be just 2, so I'll have that point. So that's the basic form of the graph of y is equal to 1 over x graph. See how this part of the graph and that part of the graph is exactly symmetrical? They are actually symmetrical across the origin. If I fold the paper across that line, then this image will exactly match with that image. And also notice that we have two asymptotes. So the first asymptote is x-axis, and the equation of x-axis is y equals to 0. And that's the horizontal axis. So we call that horizontal asymptote. Another asymptote is this one, vertical asymptote, which is y-axis. And the equation of the y-axis is x equals to 0. And because it's vertical, we call it vertical asymptote. Okay. Because we have this asymptote, when we talk about the domain, the x values, x can be any number except 0, because if x is 0, then we will have denominator of 0, which is impossible. So x can be any number except 0. So the domain will be x is not equal to 0. If you look at range, again we have asymptote right here. That means y can never be 0. There's no number if you plug that you can plug into x and to get 0 as y. So that means y can be any other number except 0. Range would be y is not 0. So any all real number except 0. Now we're going to talk about this number a. In the previous function we had 1 as our a. So this number can change. It can be 2 or 3 or half and so on. So when you have this a, what a does is, as other function, if the absolute value of a is bigger than 1, the graph stretches. That means the graph becomes higher, further from the origin. If it's less than 1, then the graph shrinks, it gets closer to the origin. And also, if a is a negative number and the graph flips. So let's, for example, in this case, a was negative 1, say if you have negative sign here, then this part will flip and will come out to this side. That part will flip against the x-axis, it will go this side. So that in that case we'll have a graph that looks like this, because we have negative 1. So that will be the graph of negative 1 over x. So that's the rule. If bigger than 1, stretch, less than 1, shrink, and then if it's negative, it flips. So let's look at the first example. What is the graph of y is equal to 5 over x, where x equals to 0? So they just include that restriction so that we don't end up with undefined value, because x is in the denominator, so x cannot be 0. So identify x and y intercepts and the asymptotes of the graph. Also state the domain and range of the function. So let's plot some points. If x is negative 10, it will be 5 over negative 10, which is negative half. If x is negative 5, we'll get negative 1. If x is negative 2.5, then we'll get negative 2. If x is negative 1, we'll get negative 5. This will result in negative 10. Well, we know x cannot be 0, so we're going to skip 0, and then we go to 0.5. 5 over 0.5 will be positive 10. So you see the values are kind of symmetrical. 5 over 1 is 5, whereas negative 1 will be negative 5. 5 over 2.5 will be positive 2. 5 over 5 will be 1. 5 over 10 will be 1/2. So if I plot these points, negative 10, comma, negative half, negative 5, comma, negative 1, negative 2.5, comma, 2, negative 1, comma, 5, negative 0.5, comma, negative 10. I connect this, I will have this curve. And then you will do the same thing, 1, comma, 5, 2.5, comma, 2, 5, comma, 1. So we'll have this symmetrical curves, two curves that are symmetrical across the origin. So let's look at x-intercept and y-intercept. We know that this graph, just like the previous example, this graph has two asymptotes, x-axis and y-axis. Because we have x-axis and y-axis, that means the graph can never ever touch the y-axis. That means there is no y-intercept, because that's the definition of y-intercept. Y-intercept means the point where the graph crosses the y-axis. Since there's no point, then there is no y-intercept. Same thing for the x-intercept. The graph never crosses the x-axis, that means there is no x-intercept. And we know the asymptotes are these axes. So the x-axis, which is y equals 0, and the y-axis, which is x equals 0. What about the domain and range? We know that x can never be 0 because it never touches the line. So domain will be x never be 0, and y range will be again y can never be 0. Okay, let's look at the second example. For each given value a, how do the graph of 1 over x and a over x compare? So let's say we have this parent function, and I have y equals to a, which is 6 over x. How does this differ from the original function, 1 over x? So now we look at a. The absolute value of 6 is 6, which is greater than 1, right? Absolute value of 6, which is 6, is bigger than 1. That means the graph is gonna stretch by 6. And also, because a is positive, it's not gonna flip across the x-axis. Let's look at this one. So if I have a equals to a quarter, I will have this over x. Now you look at a, the absolute value of a is 0.25, which is less than 1. Now in this case, because it's less number, the graph is gonna shrink by 0.25, which is a quarter. If you look at the last one, C, a is equal to -4. That means the function is gonna be y is equal to -4 over x. Now you look at the a number, the absolute value of -4 is 4, which is bigger than 1. So it's gonna stretch by 4. Also, if you look at a, that's a negative number. So if a is negative, then the graph flips across the x-axis. So it's gonna flip across x-axis. So we have two transformations going on from this a factor.